Hello, I'm scientist Dr. Soto, and welcome to Science with Olivia. I'm going to show you a mind-blowing experiment. I have my assistant here with me today, Ava. Hi! The experiment we will be conducting today is none other than the egg in a bottle.
So how does it work?
First, we boil an egg, then we grab an empty bottle and a piece of paper. Place it somewhere it's safe. Remember kids, get your parents' permission or supervision before conducting this experiment. After you put the bottle down, light the piece of paper and put it in the bottle. Quickly after that, place the egg on top of the bottle. When you place the egg on top of the bottle, it seals the bottle. There is air on top of the egg pushing the egg down and the air pushing the egg up from inside the bottle. But when you put the burning piece of paper in the bottle, it uses all the oxygen in the bottle. The air pressure on the outside of the bottle is greater. That makes it push the egg into the bottle. Well, I hope now you understand. That's it for Science with Olivia.
Bye!
I'm Dillon Turner, and today I'm going to be proving that the sound of these glasses are affected by the density of the liquids inside them. Here we have 4 glasses. One labeled W contains water partially filling the cup. Next we have W1, which has water almost filling all the way to the top of the cup. Same with W2, they're both water, except for W2 we're going to be adding a solution of salt to it. And finally we have tomato juice, which is labeled TJ, and it's just tomato juice. Okay, so like before, these 2 glasses are the exact same, filled to the exact same measurements, so they should sound pretty similar or exactly like each other. And when it comes to telling if they're very similar in pitch, if you hit them together, you should hear a nice sound. Not much ring to it. And now to identify 2 of the cups that are out of pitch, W and W1, you can hear a very contrasting pitch when you hit them both at the same time, compared to the first W1 and W2. And here we have the tomato juice and our regular water. The densities are different from each other, which you can hear by the different sounds they make, even though they are both filled at the exact same point in the glass. And now we're going to be adding the salt to W2 and making our salt solution. Now if we stir it up real quick, you can see there's salt at the bottom. And now you can hear a lower pitch and a more dead tone in the solution with water and salt in it. I'd say this has an even deader tone than the tomato juice. Kind of sounds like I'm hitting plastic. To recap, our parent solution, W1, sounded like this. And our solution W, which is also the same as solution W1, just at a different level, sounds like this. And then we have a deader tone with the salt water solution. Then we have somewhat of a mix between the salt and the water in the tomato juice solution. I'd say this experiment was a success because we proved fully that adding different materials to water solutions changed the density, which then changed the sound and pitches of each of the glasses. The thing I would change about this project is next time I would try and tune each of the glasses to the musical scale so I could prove that you could change the densities to get different sounds, and then to prove that, I'd be able to play a song.
Hi guys, my name is Alyssa, and this is my sister slash assistant Haley. Okay, we already poured the Coca-Cola in, and right now my sister will be pouring the bleach in. And the reason I am doing this experiment is to see if bleach is really one of the strongest chemicals out there. Let's see. Yeah. Okay. So this is what happened. It happened almost instantly. It lifted the black color up to this yellowish color, and I'm gonna leave it out here for a few more minutes to see if it'll lift even more. Okay. So right now, due to the Coca-Cola, it's weirdly fizzing, and it's really hot for some reason, and the Coca-Cola that I poured was like out of the fridge, and it's really cold outside, so is the bleach. So right now it's like weirdly warm, so I don't know what's happening. So it's been about an hour, and the bleach seemed to completely change the color of the Coca-Cola, and it has a little yellowish tint in person, but you can't really see that in the camera. It's still fizzing a little bit, but not as much, and it's not warm anymore. So yeah, my science experiment was successful because it did successfully lift the Coca-Cola color like I predicted. I was trying to prove that bleach was one of the strongest chemicals out there. And what I could have done differently is maybe tried it with a different color soda. Also, as I was disposing of it, I found out once I pour it, it fizzes still. And I thought that was so cool.
Hi kids, I'm Veronica, and today we are going to be looking at color changing milk. You will need milk, whole or 2%, a dinner plate, food coloring, red, yellow, green, and blue, dishwashing soap, Dawn works the best, and clean cotton swabs. Step 1. Pour enough milk in a dinner plate to cover the bottom. Step 2. Add 1 drop of each of the 4 food colors of food coloring to the milk. Keep the drop close together in the center of the plate. Step 3. Now place a drop of liquid dish soap on the end of the clean cotton swab. Place the soapy end of the cotton swab in the center of the milk and hold it there for 10 to 15 seconds. Look at the burst of colors. Add another drop of dishwashing soap to the end of the cotton swab and try again. Try placing the cotton swabs in different places in the milk. You may be wondering, what is happening? Milk is mostly water, but it contains fats and proteins. Fats and proteins are sensitive to changes. The secret to the color-changing milk is that the dish soap has bipolar characteristics and weakens the chemical bonds and hold the proteins and fats. The molecules of fat bend, roll, and twist in all different directions as the soap molecules race around to join up with the fat molecules. During all of this, the food coloring molecules are bumped and shoved everywhere, providing an easy way to observe all the invisible activity. As the soap becomes evenly mixed with the milk, the action slows down and eventually stops.
Hi guys, my name's Chamara. This is my sister Onyx, aka my sidekick. I'm from Mr. Truesdale's third period class, and this is my science project.
For today's project, we're not making no ordinary ice cream. We're gonna make ice cream with these few ingredients. First, we gotta put on our protective gear. You go slow! You're going slow!
Oh my god!
All ready to go. Now you're probably asking, what's the science behind all this? Well, when the salt added to the ice, it lowers the melting point, in which the heat from the ice pulls away from the ice cream to melt, which allows the ice cream to freeze. You're going to start by putting 2 cups of ice in the big Ziploc bag. You cannot move any slower.
Oh, okay. After struggling to put the ice in the bag, now in the little bag, we are going to put some milk.
Basically, I have no idea what I was saying here, but all you need to know was in a little bag, I'm mixing milk, sugar, and vanilla. That's literally it.
And then we're going to start the experiment.
Now in a little bag, we're going to combine milk, sugar, and vanilla.
Onyx! Onyx! Onyx!
Now in a little bag, we're going to combine milk, sugar, and vanilla.
Blah-de-la-de-da. This is us mixing the milk, sugar, and vanilla. Yeah.
Now, with our bag of ice is a bit melted because we took forever, we're going to add some reminder.
So basically, I was literally making no sense. Like, no type of sense. All I'm saying is just the science behind it and how the ice takes away the heat from the cream and turns it into yummy, yummy ice cream. And that's about it.
Inside the ice, and my lovely assistant Onyx is going to shake it. Now let's take a look.
As we can see, the milk has not creamed all the way into ice cream yet, but it has creamed a little, so we're going to continue shaking. Let's take a look. Ooh, it's creamed up a bit now.
A little bit.
But it can use some more shaking. Let's go. Let's see.
Oh yeah, it's definitely ice cream. Let's see. Open it up. Oh my god, now she's struggling. Look.
Ice cream.
Is it ice cream? Yep. Now we're gonna taste test it. I put it back in the bag because it was kind of melted. So, voila, ice cream. Let's take a look inside again.
I don't have some syrup.
Alright, shut up.
Okay.
You can't see it. And that is my science experiment. We're gonna try it now.
Sweet.
Is it too sweet?
A little sweet.
Delicioso. It's kind of melted.
Oh.
Enjoy this while we eat this super fast. Nothing more in that bowl, girl.
Okay.
There ain't nothing more in that bowl. What is this? Thank you for coming to my experiment.
You're welcome.
What? Thank you for watching.
Bye.
Hello there. Welcome to the science experiment today. My name is Nigel and I'm going to be showing you what I'm going to be doing today. Today, this science experiment is based on Newton's third law of motion. And what chance of Newton's third law of motion, you ask? Well, Newton's third law is the state that for every action or force to be precise in nature, there is an equal and opposite reaction. In other words, if the first object exerts force onto the second object, then the object also exerts an equal opposite force to the first one. And today, for this experiment, I'm going to be doing a science experiment purely by using marbles. If you know what marbles are, they are basically spherical or the flat-shaped versions. And to do that, here's my ramp I'm going to be doing. So, this is only the first experiment right now. For this, you're going to need right now, flat surface marbles, like these. I decided I would do it in a rim version since it's more different. For this one, you're going to tend to put in 4 to 5 of these in the middle. Grab yourself a big marble just in case for the second experiment. Grab yourself 1, 2, 3, 4, 5, 6, 7 colored marbles that have a good amount of distance. And for this, I'm going to be using these 7 colored marbles. And that's for that. I'll add in 2 more just to become a wall. Okay, here's the first one I'm going to be doing. Watch what happens when I start using no force onto the marble. You see that? It hits one of those clipboard parts right here. Best chance if you have some flat surface, you better keep it with you. Now watch what happens if I do it with some force onto it. See that? I've just exerted force onto this one right here. And there's more to that. If you apply enough force to it, you have a better chance of seeing how much force it applies. That's why it's basically a discovery on how to use motion right. Now watch what happens if I do it with a thumb. You see that? It just knocks out that one in pure fully motion. Now, imagine if you want to do it like twice. This time grab 2 marbles instead. Watch what happens if you apply no force or 1 force to one another. See? Both just hit the wall. But one actually hits that one here. And watch what happens if you put in a lot of force into it. It hits two right above here. But leaves these ones out on the border. Right here. You can't really see them because I'm pixel. Because there's no gap between them. I got them right here so you can actually see them. Now watch what happens if you use a big one against these ones. Watch what happens. There's no bump into them. It didn't apply enough force into it because it was slanted. Now watch what happens when you apply enough force to it. It's the exact same thing. But if you apply enough super force to it, one just actually got hit out of the border. So, there's more to that. I want you Weisser Park students trying this experiment at home. Now, say for instance, what if you try with a spherical marble? This time, try putting enough marbles. Try putting 2 marbles against the flat ones just because if you're doing it in a rail, it'll basically bump in and fall. Now watch what happens if you apply force to these. And now watch what happens. That was one, so it was a complete fail. Test 2. Take 2. This is the second fail. And roll out. Sorry about that. Try again. Now apply force, but only a smudge. Now watch what happens if you apply enough force into it. It only hit one of them. Now watch what happens if you use one of these big ones. That just pulled in enough force to bump a lot in the collision. So, I explained to you how in Newton's third law of motion really acts when using marbles. I want you kids at Weisser Park to try this experience at home. And if you do, let me know the results you've gotten. And that's all this science experiment I have for today. Thank you all for enjoying this, and I hope you learned something about Newton's third law of motion using marbles. Hope this helps out. My name is Nigel, and I'll see you guys later. And stay safe, wear a mask, be sure to wash your hands. Peace out.
Okay. Hi, my name is Merari.
And my name is Kailani.
And today we're going to be doing a bottle rocket experiment.
So, we're going to be taking vinegar, baking soda, and this constructed bottle rocket, and we're going to try to make it launch.
So, we believe that baking soda and vinegar, when they come together, they have a reaction. And we believe that if we confine and keep that reaction in a water bottle, that pressure will build up enough that this water bottle will be able to explode and fly through the air. All right, so what we have is we have this water bottle filled with vinegar about
halfway.
Yeah, about halfway. And what we have here is little paper towels filled with baking soda. So when we go outside, what we're gonna do is we're gonna uncap. Yeah, we're gonna uncap this water bottle. We're going to take these and we're going to very quickly drop it into the bottle, and then we're going to take this cork and put it in the water bottle to kind of seal it up. Okay, then we're going to flip it over onto these pencils and run away.
It should launch, and
we hope that the pressure will build up enough that the water bottle won't be able to keep it and it will fly through the air. All right,
so let's take it outside and see what happens.
What I'm going to do is I'm going to uncap this bottle, and I'm going to take all 3 of these things of baking soda, drop them in as quickly as I can, cork it, hopefully I might be able to shake it, and then I'm going to tip it over onto this table and we're going to see what happens. Okay. Oh, good.
Let's go for it, dude. You got it.
Oh no. Oh no, no, no.
Hurry! I don't know.
I'm trying to stop it.
Try to screw the cap on.
I don't think anything's gonna happen.
It's making noises.
I should maybe like...
I mean, they are still dissolving, but I don't...
I may let some air out.
I don't know.
Maybe I used the wrong end of the cork.
I don't know.
Maybe we just didn't have enough baking soda.
Maybe.
Yeah, I think the reaction is over. It did kind of... The water bottle did get bigger, but it didn't get enough to explode. I just don't think we had enough baking soda.
Yeah, that must have been our problem.
And when the cork fell out, the initial big release of gas just kind of escaped.
We must have missed our biggest moment.
Yeah.
But it is like very packed full of gas right now.
Oh my word!
Yeah, like can't squeeze it. Try maybe unscrewing it lightly and see what happens.
Oh goodness. How do you... Okay, now it's upside down. I'm really confused.
Just like...
Which way is it? I don't remember which way.
It's that way.
So what happened was I started to unscrew the cap slightly. I don't even know where that is, but then all of a sudden it was unscrewed enough that it kind of exploded.
There was a lot of gas trap that we just didn't realize, and there was enough pressure that it...
Yeah, I have vinegar on my pants and on my sweater.
Yeah, we both got hit by the recoil.
Yeah, we're both kind of wet.
So the experiment was successful then.
It was successful. I don't know how far high up it went. I don't think it went.
We didn't catch it on video, but it probably went at least 10 feet up.
At least 10 feet. But it was a success after a little bit of not success.
For future success, for like to do this experiment better, I'd use baking paper towels that were thinner and maybe like a better cork that actually like works.
Alright, let's see if we can get this cork out of here. It actually may just be stuck.
It may just be stuck in there forever. Okay guys, so that was our experiment.
Yeah,
cool.
Alright, hope you enjoy science.
Woo!
Hi, I'm Alex, and this is my little sister Raquel. Today we'll be doing the vinegar and baking soda science experiment with balloons. You're going to need vinegar, baking soda, empty bottles, balloons, and food coloring in a funnel. They're optional. You don't have to do it, so. We already added our food coloring, as you can see. So now we have to add baking soda to the balloons. When you attach it to the funnel, put in 3 to 5 tablespoons of baking soda. Shake it up a little bit. You have to shake it up a little bit so that you can get it through to the balloon. Now, when you remove it, just put it to the side. Add your second balloon, and just repeat the process. Okay. Now remove that balloon as well. Now we're going to add our vinegar. When we add our vinegar, half a cup or a cup of vinegar is just fine. It got a little messy. That's okay. Okay, so when we attach the balloons to the bottles, you have to make sure that you don't let the baking soda get into it. Just attach them and leave it alone for a little bit. Now, we're trying to prove that the carbon dioxide that escapes when these two chemicals will react will blow at the balloon. So we'll wait and we'll watch and see what's going to happen. It rises and it's blowing up the balloon. This one not so much, but we'll see. Look, it's working. Okay, so our science experiment was successful.
and wait until it dies down a little bit. When these two chemicals reacted, they let off a gas known as carbon dioxide into the balloons. Normally, when we breathe into balloons, we do the exact same thing. We breathe in oxygen and we breathe out carbon dioxide, just like it did here. What we were trying to prove was that there was just another way to do it. And these are now blown up, so the science experiment was successful, as I already said. And I feel like I could have put a little bit more of an ingredient to a different one, like maybe add more baking soda to this one, or more vinegar to this one, just to see how the outcomes would be different. But overall, it was a success.
Hey guys, my name is Britany and today we're going to be making oobleck. My partner in this video will be my cousin Alex. Okay guys, so for this experiment we're going to need one glove, some food coloring, a plastic container, some cornstarch, and just a cup of water. Okay, so the first thing I'm going to do is I'm going to put the glove on. Next, he will be pouring some cornstarch inside the plastic container. Okay, and I think that is pretty good. Next, what we're gonna do is we're gonna add some water. So we're gonna add the water. No. Yeah. Okay, and once we have this mixture, we're gonna go ahead and add our food coloring. And right here we have our colors, which are blue, purple, and green, and my cousin decided to do green, so that's the color we're going to be using today. And he's going to go ahead and drop 3 drops into it, more in the middle, right there. And then once we have this mixture, we're going to just go ahead and mix it all together. So we're just going to go ahead and mix it all together. After you have mixed it for a couple seconds, you're gonna start filling it to the way you want it. Okay, and I believe we already have what we wanted to get. So our oobleck is done, and you're gonna know when it's done because once you hold it, it's just gonna melt right away. But once you like squeeze it, it's gonna turn into a solid consistency, as you guys can see, and then it's gonna start melting. Okay. So yeah, thank you for watching, and this is how you make oobleck.
When she drop hers, it's over.
We should have threw it up in there.
Okay, today, boys and girls, I'm gonna show you an experiment that shows you what a chemical reaction can do. So first, you're gonna need a cup, a little towel because you don't want to get all messy, some baking soda, and some vinegar. Oh, and a glove. You can use a glove or a balloon, it doesn't matter, just something that can expand. So you're gonna pour the vinegar inside your cup. About that much should be good. Then you're gonna get your glove and your baking soda, and you're just gonna start dumping in there. You don't really need that much, you know. It's just, you know, having some problems taking it out. There you go. That should be good. And then you wrap your balloon or glove, whatever, over the bottle or whatever you're using. And then you just let it. And it's gonna pop. You might want to hold it, you know, so nothing happens. And that is.
Hi, my name is Tanija. I'm in your third period class, and today I'm going to be doing the experiment. The experiment I'm doing is the soap and pepper experiment, so let's get started. Okay, I have the pepper in the container right here, as you can see. And then I'm going to put soap on my finger, so yeah. Okay, so I have the soap on my finger. Okay, now I'm gonna add it in the thing, so as you can see, watch. And the pepper has moved away from the soap. Yeah, see, it's around the edges now. It was all right here, but now it's around the edges. So the soap must.
Hi, for my science experiment, I will be doing the floating egg experiment. For this experiment, we will need 1 egg, water, a tall drinking glass, salt, and a spoon. I'm going to be doing this experiment in my bedroom, but you can do it anywhere you want. For this experiment, I want to prove that I can make an egg float in water. Okay, for this experiment, you will just need 1 glass of water, but I put 2 to see if this one without salt does the same thing as the one that has salt. So let's put the egg in to see if it floats or not, but slowly so it doesn't break. As you can see, it goes down. And let's do this one. We need to put water. You're not gonna fill it till you're just gonna leave it like that. And you're gonna add the salt. I think that's enough. Yeah, that's enough. Then you're gonna stir it till it's all combined. I think that's good enough. Let me see. Yeah. And then you're gonna add a little bit of water without salt or anything. You're gonna put it slowly. And you need to put till, I think that's good enough. As you can see, it's like right here, like this one. So now we're gonna add the egg to see if it's true that it's going to float on the water or if it's not. So let's put it, be careful. As you can see, it floats, and I think that I proved that an egg can float on water. So I'm very happy. I didn't think that it was going to happen, but it did. As you can see, this one it's in the bottom and this one it's floating.
Hi guys, my name is Bonnie, and this is my partner Kimberly. is 3 clear cups, and then you're going to fill them with water, these ones, and 1 empty. I prefer you guys to use plastic cups just to be safe. Then you're going to get a paper towel, and then you're going to cut it in half, which I already did. Cut them in half, and it should look like this. And then you're going to fold them in half like this, and then fold it in half again like this. So then you should get it should look like this. Okay, those are wet. So then you're gonna get there's food coloring. We got blue and green, and you're only gonna put food coloring on the ones that have water. So I'm gonna add 3 drops. 1, 2, 3. Okay, and then you're gonna go ahead and mix it. And yeah, I went ahead and mix this one. Okay, so then you're gonna grab the paper towels and put them in like this. They both have to be in the middle. So like this, and the water is gonna go up and then come into the middle. Then you wait. Hi guys, so it's the next morning. It is 10:20. As you can see, the experiment worked overnight. It turned into this greenish bluish color, and the water, you can see, went down. So yeah, this experiment was really interesting to do and to watch. So thank you guys for watching. Bye.
Today's topic is about density. What's this? We have oil and water. The reason they don't mix is because of density. Oil is less dense than water. Now, if we were being specific, water has a density of about 1 gram per cubic centimeter, and oil has 0.93. And if I were to shake up the water bottle, it would look like this before going back up. Let me do it again. See? Now, the thing about density is it measures the amount of compression in a substance, and compression meaning molded together.
So today we're gonna do elephant toothpaste.
And for this you're gonna need activated dry yeast, 10% hydrogen peroxide, dish soap, and food coloring, along with a little bit of water. So first you have to open your hydrogen peroxide, obviously, and then put a lot into your cup. So after you put that, and add your dish soap, Then you add your food coloring. The amount of food coloring you put is up to you.
We're gonna put that much because...
Yeah, if you want to see the color more, you can add more food coloring. Then just stir it. So after you stir it, you're going to have to put your yeast into a separate cup and add water. This stuff looks so weird.
Yeah, I want to pour it.
Yeah, we gotta put 2.
2?
Yeah.
Okay, we're gonna put 2 yeast,
2 little
two
packets
packets
of
of
yeast.
yeast, and then the yeast makes it fizz up.
Yeah, when the yeast is paired with the hydrogen peroxide, it should cause a chemical reaction and cause it to fizz up. So that's the goal. Then you're just gonna add some water.
I'm gonna mix it up.
You can need more.
You don't need more water.
Yeah, it's gotta be like liquidy. So you want to get it to a liquidy consistency before you pour it in, and then you just stir it up to get it to a liquidy consistency. So yeah, stir it up.
And then I'm gonna pour it in here. And you see it rises up.
And then it comes up.
It looks like a mushroom. And yeah, it fizzes up because it's like off the toothpaste. But I don't know if you could touch it.
Yeah. So we're gonna try to add a little bit more water.
So it can like fizz up. It went kind of slow. I thought it was gonna be like.
Yeah, and if you add more hydrogen peroxide and more yeast, it will go faster. And you will get kind of a better reaction. We're just gonna add a little bit more to it. See if it continues. So yeah, this was successful.
It was very successful. I didn't think it was gonna work.
I didn't think it was gonna work as good. But yeah, very successful. And you can touch it. It felt like, you felt it? It felt like cloudy.
Oh,
it just smells like dish soap.
Yeah.
Oh.
We touched it.
When you touch it, I don't know if you can see it, but when we touched it, it made like it kind of covered our fingers.
Yeah, don't put your hands in it.
I mean, you can if you want to.
If you have gloves, then do that.
Yeah, but yeah, it was successful for the most part.
Hello, my name is Sam, and like most sane people, I believe that there's aliens. But there's some crazy people out there that don't think they exist. And I proved them wrong, but I have too much homework. So instead, I decided to create a machine that does it for me. His name is Robert. It stands for Running Operational Buzzing Electronic Robotic Technology. And he is sound control, so if I just switch, he turns at my will when I talk. But before I teach you how to build him, why do we use rovers like Robert? Well, to tell you, they go where no human can really go, like in outer space on Mars, or in the deep ocean floor, or my favorite, in a volcano. First off, if you're gonna build Robert, you're gonna need a computer like this or an iPad. And then we will also need to go to the Lego Education We Do site. And then after I will show you how to build your very own robber. But if you need, you can also just go to the website and you'll have the instructions there. Okay, now we're gonna start building robber. The first thing is you want these two pieces here and put them together. Next, you're gonna take this piece right here and put it right on top. After that, you're going to take these two pieces right here and you're going to put them on top right, like this. After you do that, you're gonna take one of these pieces and set it right here. After that, we're just gonna move this aside and put these two together. After we do that, we're gonna take one black brick like this and put it on. Now that we got that, all we need now is just a connector. Like that. Then after we do that, we take this one we already built and just put it on. Like that. After that, we're gonna take one blue brick like this and put it right here. After that, we're going to start with one of these pieces, and then we'll just add on one of these. Don't put it all the way, just put it in a little bit. After you do that, just put it through this middle piece here. After you do that, we're gonna put this, trapping it in. And after you do that, we're going to put this and stick it through. It should be around even. Doesn't have to be perfect, but the closer you are, the better it is. After you do that, let's put in these two on each side. Like that. Then we'll move that to a side for a minute and get the actual motor. The motor, you're gonna put in this piece on the end. This is actually what's gonna move. After we get that, we're going to take one of these tires and put this in. Pushing it through. After we get that, we're gonna stick it straight on top. Now, here. Next, after we do that, we're gonna get what I like to call the brain. This piece right here goes like this. And that's where you get your batteries and everything. It basically is what connects to your computer and gets everything working. You set that straight on, and it's on, and it's perfectly fine. Afterwards, you're gonna stick this piece, it doesn't matter which one, they're both the same. You just gotta get it in. It sometimes takes a little bit, but I got it. After you get that, you flip it over, and you get two of these. These will just go along the back, just so then it's easier when it starts rolling, so it just works like that. After we get that, it's gonna take a little bit. Next, you're gonna need two of these black soft pieces. One of them will go straight on in the front. Nothing. The other one, you're gonna need a green piece to go with it to make it a little bigger, to balance everything out. Next, after you do that, you're also going to need to get these two blue wheels, basically, and put them in. Push them all the way until they can't push them anymore. After you do that, then you're gonna get this rubber band right here. After you get the rubber band, you wrap it around like this, and you try to get it straight on with the wheel. So then when the motor starts going, it actually turns this entire wheel. After you get that, you keep it flipped over. You get these two tires, and these two inner tires basically, and you push them in. You do it twice, and after you do that, You just push them through. Once and twice. And then we move that to the side for a minute and we get the face. You get this piece, you put this on top. After you're done with that, we get 2 white pieces. These go on the back, and you see how these nozzles are right here? Well, those are gonna be facing outwards. Not forward, but outwards. After you get that, you're gonna take 2 of these, and these basically just go on the side, on the top, and then cover the side. Like so. Next, we're gonna take these levers here, and they're basically gonna be like antennas. They're just for show. This entire head's just for show. Next, after we got that, we're gonna make Robert's face. We're gonna put 2 pieces right here. And then the last eye right there. Now, as you see, when we have this, there's just 2 hinges. That's where the ending comes in. You're gonna take this and put the little balls on each side. Next, you're gonna push this and put it in on both sides. If the antenna thing comes off, it's okay. It happens all the time. Just put it back on. And then that is how you make yourself a Robert. So when you go to the We Do 2.0 website, you're gonna be able to download an app. You wanna download that app because it will take you to this site right here. This is where you're actually gonna code your own Robert and tell him what he's gonna do. First thing you wanna go to is a new project right here. Once you click on that, you'll get your own piece. This piece right here, the green arrow, that's just gonna start the code. Down here, this is all what you're gonna tell it. So for instance, this one, right here, this one's telling it to move. And this bottom piece you see right here, this tells it what speed it's gonna be. It can be from 9 to 0, meaning it's not gonna move at all. The higher number it is, the faster it's gonna go. I'm just gonna put it back at an 8. And then after that, you can also remove them just by throwing it. But this piece right here, this is a delay. So it basically is just gonna tell you how long that code is gonna last for. You don't need it, but say you put this code piece right here up, it's basically gonna go on forever unless you have a stop or you have this. Then it just tells you how long that code's gonna go on for. This X right here ends the code entirely. It just says that after this is done, everything stops and the robot is just gonna stop. These 2 right here are the same. Robert is one of many different robots, and some of the robots can move 2 different directions. Robert can only go forward and backwards. So when you pick one of these, they're exactly the same. And it just basically says it's gonna go the opposite direction from where it was going in the first place. This piece right here is just gonna tell you what, it's just gonna make it do a little bit of the music. And then when we get to here, all it just says is how it's gonna go, like how you're gonna start. You can do it with just pushing the button, or you can do it by pushing a keyboard key. And this piece right here is the most important. What this is saying is that this loop will go on forever. And it will just keep repeating and repeating and repeating. Now we'll get into controls. So you can see these blue pieces on the bottom. You can remove them. But my favorite out of all these is this, the microphone. What the microphone does is lets you talk and then the code will happen. So say you have
let's put this, the start right here as a moving forward. Then you put a wait, and then you put a reverse. Just get rid of that code right there. It will keep going forward when you start it. Then when you talk or say something, it will reverse. Because this code only activates when you have to talk, which is indicated right here. Now, when we get to this right here, all it does is just randomize the times and speeds of everything. So if I put this here, it's gonna be a random speed, and if I put it in this point right here, it's just gonna randomize the time of the duration of the code. And also, here's something I just wanna show. If you see this right here, I can connect my Robert to my computer by doing this. You click on this button, you click on the button, and then he's gonna start lighting up. It should connect right here, and right when you get him, it clicks, and he is hooked up. So now if I push the code, he moves. And if you ever want to stop it but forget to put it on, then you can just push that red button right there, the red square.
So now you know how to make your very own Robert, and I hope someday you will prove to any of the non-alien believers that, in fact, aliens are real.
Hi, my name is Grace, and today I'm going to show you guys a cool science experiment. So everyone knows you could put a candle out by pouring water on it. But today I'll be trying to prove that there's another way you could put out a candle. Let me show you how it's done. First, we'll need a candle, of course. Then, we'll need baking soda and vinegar. Start by putting equal amounts of baking soda and vinegar into a glass. Try and keep as much air as possible out by covering it up with your hand or a napkin. I'm using a napkin and securing it with a rubber band just to be extra careful. And there we go. Then pour the gas that we've created into a different glass to keep the gas and liquid separate. Make sure to not let any liquid in this glass. I'm using a rubber band and a napkin again to make sure that no gas escapes. There we go. Now, in a moment, we're going to take the glass of gas and pour it onto the candle. But first, let's make a hypothesis. A hypothesis is a prediction about what you think might happen. All scientists use them. I hypothesize that when I pour the gas on the candle will immediately go out. Now let's see what happens. Look, our candle went out, which means our hypothesis was correct. Now, let's go over why this experiment was successful. When we mixed the baking soda and vinegar, we created a gas called carbon dioxide. Carbon dioxide is the same gas that we produce when we breathe out. Therefore, when we poured the gas onto the candle, it was essentially the same thing as blowing out the candle with your mouth. That was today's science experiment. I hope you guys enjoyed it and learned something new. Bye!
Hi, I'm Parker and this is my science experiment. I'm here today with my friend and assistant Elliot. We're gonna make a rocket out of pasta.
A pasta rocket, if you will.
What you're gonna need is a bottle of hydrogen peroxide, a 1/4 teaspoon of yeast, a jar with a lid, make sure the lid has a hole in it, and a piece of pasta. You'll also need a lighter to start the rocket, so make sure you're wearing safety goggles and have an adult to help you. This experiment shows what happens in a hybrid fuel rocket. Hybrid fuel rockets are rockets that work off of liquid fuel, solid fuel, and gas fuel, a combination of those three. Fill the jar 3/4 of the way with hydrogen peroxide. Then take the yeast and mix it in. This will cause bubbling because the oxygen is escaping the mixture. Quickly put the lid on the jar and then put the pasta over the hole. The oxygen will now be flowing through there. Then light the pasta on fire. The flame caught on the air being pushed out of the mixture, and if this were a real rocket, that is what would propel it through space.
Wow!
Remember, if you're gonna do this at home, make sure you have an adult to help you with the lighter. Have fun sciencing.
Hi guys, I'm Christian Guevara. I'm from Mr. Truesdale's class, and I'm going to show you guys why it's important to wash your hands, especially during this time. So for this experiment, we're going to show why it is important to wash your hands with soap. The first substance that we need for our experiment is soap. The second substance that we need for our experiment is going to be black pepper. Then we're just going to need 2 bowls. Doesn't matter the size really, but I prefer a small one for the soap. So for one of the bowls, you're going to pour the whole thing with water. Doesn't really matter with size. And then you're going to have to pour black pepper onto the water. I would put a lot so it's the whole top surface is covered up. So if we think about black pepper as bacteria, without the soap, you can see how that bacteria is now spread at our finger. But with soap, you see that none of it has gotten on our finger. Now this is why it is very important to wash your hands during this pandemic still going on.
My science experiment, I'm trying to prove how things float in water. So what you'll need is 1 cup of water, 3 to 4 tablespoons of salt, and 1 egg. So if you put your egg in your water, you will notice that it does not float. And that is because the density of the egg is higher than the density of the water. So if you put some salt in your water, stir it up. Your egg should float. I know you can't really tell because my water's kind of foggy, but it is floating. And this is because when we added salt to the water, the density of the water is now higher than the density of the egg, so the egg floats in the water. I think that my experiment was successful because I did show how buoyancy and how things float in water.
Hi everybody, let's go ice fishing. So what you're going to need are some ice cubes, your fishing pole, a piece of string, and some salt. So the first thing we're going to do is place some ice cubes on a tray with some water. We're going to take our string and get it wet in the water, and then place it on as many ice cubes as you can. I have 3 on my plate, so I'll put it on these 3 like that. And then what we're going to do is we're going to take some salt that I poured into here, and we're going to generously sprinkle it over wherever the fishing pole is, so our string. Okay, that looks good. And now what we're going to have to do is count to 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, let's see how many fish we caught today. Wow, we caught 3 fish. Now you may be wondering, how does our fishing pole attach to the ice? Well, the salt causes the water temperature freezing point to drop. So when we put the salt on top of the ice cubes, the water starts to melt because the freezing temp has lowered. And when the water melts, the salt and water solution starts to dilute. And when this starts to dilute, the ice starts to freeze again. That's how our string attaches to the ice cubes.
Alright, what's up guys? For my science experiment, I'm going to be showing you how to explore melting ice. So first, you get like a container that's shaped like a sour cream bowl or a whipped cream bowl or a tug-of-war bowl. Then you get 1 cup of hot water, 1 cup of tap water, and you both just pour it in. Alright, then what you do is put it in the freezer and just wait till it's a freeze. So, as you know, it's out the freezer now. So I took it out and left it here for like 5 minutes straight, and then I came back and it's what it looks like. Alright, so then I'm gonna try to test it out. And a little piece broke off. This is a penny. I just put my hand on it 30 seconds. It's very cold though. And it's not coming off now. Try a toothpick. It's very hard. Oh, you can't see. Toothpick doesn't really do nothing to it. It doesn't even poke holes in it, so. Alright, so still the same thing. Now I'm gonna get some table salt and see what that does. If it melt or any type of. You see how it's like making that noise. That's cool. Oh, it's cracking. Well, it is melting down. Seems like it. I'm gonna try to. Yeah, it's a lot of water right now. Feels really bumpy now. Now let's try to flip it. Ooh. Let's try this way. Wow. It's turning like, I don't know how to explain it. It's like, now the toothpick can finally poke it. Well, I don't like it's really doing too much to it, so we're gonna try to put it in the microwave for 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, it's making some type of noise. Some water didn't melt too. It looks like some type of ashtray. But it looks cool. It is peeling apart though. Alright, so I got a cup full of salt. I'm just gonna pour it in this circle right here. Really turning, might turn into like a crystal type. That's cool. It's actually cool. And now it's starting to break. I see it's a hole right there. And pour more salt on. It's a lot of salt. Put my hand in it. The salt looks like some type of snow. Alright, so I'm just gonna try to.
Okay, so you got a half cup of hydrogen peroxide.
Pour this in.
Okay.
And then 1 squirt of dish soap over here.
Yep. Good. Now take both of those things over there so they don't get messed up.
Yep. Wait a second.
You gotta mix it up. Okay.
There we go. These don't get messed up.
Yeah, there you go.
Open this up.
Okay.
Hopefully this one works. I feel
That's
like
yeast.
I honestly feel like this will work better for one reason specifically. I just think the whole thing with the hydrogen peroxide being like a thick cream looking thing just didn't work.
You know, you can mix that up in the big cup over there, and it'd you'd be able to stir it easier.
This one?
Yeah.
Okay. 2, 3.
Yep.
Sometimes I hate the caps on bottles. I'll use a big one since it's not as...
Sure. Dump the yeast in. Gonna give it a squirt of color again too?
Sure. I don't know.
Make sure you get all the yeast that's on the side.
Move it down. Does not look right to me, but hopefully it works. Sometimes the reaction takes a while. Like it takes a little... Ooh, boy, that stinks.
It's yeast.
That makes sense. Okay. Green again. It'll just pop out the top.
It kind of unsqueeze it, or untwists. There you go.
Oh wait, so I just like that?
No, you got to take the cap off it.
Oh. My mistake. Okay. in.
No.
Mix this. Mix
I don't think you even need to do that.
Well, I'll just do
It'll mix up anyway when it mixes or when it reacts.
Well, I'm going to do it anyways.
And before I dump it in there, I would take your iPad and your paperwork out of the way.
True. Okay. That's enough.
Okay.
Okay. I'll pick this up.
Well, that's a better reaction than we got.
Yep.
The first time.
And that's with the soap, if I'm not correct. If I am correct. So that'll actually work. Okay then.
You want to get Mom to show her?
Yeah, I'll go get Mom. It looks very funny.
So I'm gonna be doing elephant toothpaste for my science project experiment. So yeah. So I don't know what it's gonna prove, but I think it will be cool. But well, I think it proves that a good chemical reaction. Yeah. So in this, I have hydrogen peroxide and water. Well, no, and soap. Sorry. So we're gonna put it down. There. See if you can see it. Okay. And then we have our yeast and water. And we're just gonna pour that in there. Ooh. So I think it worked. Yeah, because it looks like toothpaste. Yeah, I think it worked. But what I would try next time would probably be less hydrogen peroxide. Because when it started coming out, it was like really watery. So I think that was bad. So yeah, bye.
Alrighty, hey there kids. Today we're going to be doing a science experiment. Today I'm going to be doing elephant toothpaste. And you asked me, what is elephant toothpaste? Well, elephant toothpaste is a foamy substance made up mixture of ingredients. So first things we're going to do is going to take this and we're going to take our hydrogen peroxide and we're going to get 1/2 cup and pour it in. Make sure to open it first. And you're going to do this very carefully. All right, and then after that, you're going to take your dish soap and put a big squirt in there. All right. Then after that, you're going to go ahead and put in your dye. And I'm choosing blue. I'm just going to put a few drops of dye in there. And if you want it to look like toothpaste, you put it at the outer rim. But I'm just going to go ahead and put mine in. All right. Then after that, in a separate measuring cup here, you're going to go ahead and put in 3 tablespoons of water and a tablespoon of yeast, dry yeast. 1, 2, 3. Now let's get our yeast here. And we're going to go ahead and pour that in. All right. Then after that, you're going to give it a little mix. Very carefully. Then after that, you're going to carefully pour this into that, and it'll make your Elf toothpaste. Voila! There you go, elephant toothpaste. And it'll keep going for quite a while. And it's going to foam up quite a bit. And just make sure you have a nice open space for it so it'll keep foaming up. Alrighty, so science experiment was successful. And I think for me, what I would do to make this a little bit better is probably have your dry yeast a little bit more room temperature. And then you really can just play with it on the amount of soap you want to put in or any of that. So thanks, guys. Hope you guys enjoyed it.